Well, good morning. You are probably watching this either because you're in school and I can't be with you today, or maybe you've missed school and you're doing some catch-up. Anyway, I thought I'd start with a quick recap of what we've been covering with section 9.2. We had finished talking about forces and buoyancy in section 9.1. We had done, we talked about average density and how different man-made things and some natural things can manipulate average density in order to change their buoyancy and either move up or move down, like fish or submarines or hot air balloons. We even learned about the hydrometer. So those were the topics in section 9.1. In section 9.2, we moved on to talk about pressure and how it's related to force and area. And for the last part of this section, we're going to be talking about and jotting some notes down about compressibility, hydraulics, and pneumatics. So hopefully this will give you a little bit of background for the project if you decide that you want to make a hydraulic machine or a pneumatic machine, just so you can understand a little bit more about what these terms mean. So in this section we talked about how pressure is related to force and area, how it's directly related to force and indirectly related to the area it's acting on. We talked about how it would hurt a lot more if I put all my weight on the tiny back part of the shoe and stepped on someone's foot, or a smaller pressure that they would feel if I put all my weight on the whole sneaker or a whole full-length boot. Okay, so that's how it's indirectly related to area. It's a lot bigger if the area is small, the pressure that's felt. We discussed the formula for pressure, and we looked at the units for pressure. So pressure is force over area, so it's Newton per meter squared, which is also known as a Pascal. And a kilopascal is 1,000 of those. We looked at other units that they've used for pressure, and we also looked at the triangle, just like the density triangle, the triangle that's used for calculating pressure. Right? Then we did a number of problems, so you should have seen how to apply this. If you want pressure, it's force over area. If you want area, it's force over pressure. And if you want force, it's pressure times area. So we did a few practice problems and showed the given information, formula to calculate, substituting, figuring out your answer, the fact that the units can go between newtons per meter square and Pascal, and the importance of closing with a sentence. So we looked at probably 3 or 4 examples. Okay. And this we should have already seen, but you can always slow it down and watch again if you wanted to go back through these problems. Just trying to do a quick recap. So, there are some problems in the book that you could try, and the answers you can check. But today we're going to start talking about compressibility. So, compressibility is the ability of a substance to be squeezed into a smaller volume or space. So if you look at the word, within the word, there's the word compress, and even press. So if you think of what those words mean, it means that you can squish them or squeeze it into a smaller volume or space. Only certain types of matter can be compressed, and they basically need to have enough space between the particles so that you can squish them into a smaller volume or a smaller amount of space. So if we look at solids, liquids, and gases, gases have large spaces between the particles, so it makes sense that if you apply a pressure, the particles can be squeezed together. So you can pause at any time and jot down notes, and then just press play again. So gases, we say, are compressible. There's the gas. You can see the space between the particles. So if we applied a pressure, we can squish them into a smaller volume. Even when a gas is compressed, there is still a bit of space between the particles. Liquids and solids, there just really isn't enough space between the particles. There's very little. So when a force is applied, the particles cannot be squeezed together into a smaller volume. In other words, liquids and solids are what we say incompressible, not compressible. You start off with very little space between them. You can see on the right it's trying to squish them into a smaller space, but it can't because there's not enough space between the particles to start. This is just comparing a gas and a liquid. So with the gas, there's spaces between the particles. You can squish it down into a smaller volume. The liquid, you just can't. There's not enough space. So, oh, look, we're dealing with Pascal again. Pascal did a lot of research with pressure and compressibility, and his law that he came up with through his studies states that the pressure applied to a confined liquid is transmitted with equal force through the entire container. And this law is pretty important when it comes to hydraulics. Okay, so again, the pressure applied to a confined fluid, so a fluid that's inside of tubing or inside of some kind of a container, it's transmitted with equal force through the entire container. When you squeeze a tube of toothpaste, you're demonstrating Pascal's law. When a confined fluid is squeezed, this creates static pressure. Static pressure is referring to pressure where the fluid does not move. Okay, so fluid does not move, but it's capable of carrying a force. This is the principle that lies behind hydraulic systems. So if you think of the orange line in this picture having a fluid inside of it, completely filling the tubing, okay, the force from a fluid at rest can be used to apply brakes on an automobile. So if the person that's driving pushes on the brake, it causes the force to be transmitted through the orange tubing, through the fluid, and applied at the brake level to stop your tires from moving. So hydraulics is a field of physics that involves the study of pressure in liquids at rest or in motion. There are two types of hydraulics, or two areas of study in hydraulics. First is referred to as hydrodynamics. And dynamic means, or kind of refers to things in motion. So, and hydro at the first refers to water. In this case, you can think of fluids in general. So the study of liquids that are in motion. An example would be studying how hydroelectric power allows us to use the flow of water in order to harvest energy. Okay, so to get energy in order to power things. Hydrostatics is the other area of hydraulics. And static refers to things at rest. So when we talk about hydrostatics, it's the study of liquids at rest. So an example would be like the fluid in the brake line, or applying forces through liquids in closed containers in order to move things. Sorry. A hydraulic system is a system that uses applied force transmitted through a liquid to move something else. So in your project, if you choose to make a hydraulic machine, then you'd be applying a hydraulic system. You'd be creating a hydraulic system in which force is going to be applied through a liquid. You'd be using syringes with tubing that has water in it. So, can you try to imagine different things around that involve hydraulic systems? Oh, a dentist chair. A dentist chair would be one. The jaws of life, which they use at accident scenes often in order to apply a large force and quickly be able to, say, remove a door or move parts of the vehicles to free someone. Dump trucks. The car hoist at the garage. So you apply a small force to the button or the control, and it delivers a larger one in order to lift a whole car up to be able to work underneath it. Many other types of machines. So you should be able to recognize if certain ones would be hydraulic or pneumatic, or give examples of them. You should understand the difference between them as well. So when we are dealing with hydraulic systems, there is opportunity for hydraulic multiplication, and that basically is the ability to increase and transmit a force through a liquid from one point to another. So to increase or multiply the force that's transmitted. So basically you have a small force in one area and it exerts a really large one at the other area. So they can greatly multiply the force exerted by a liquid. Small pressure on one side of the system is transferred to a larger pressure on the other side. I think I have a picture on the next one to kind of demonstrate it. So a small force applied over here, okay, at the controls. So you can see the person has the controls, okay. A smaller force applied on that side is going to be exerted through the fluid to the hoist. Okay, a small force over a small area is turned into a large force over a larger area. So the hydraulic multiplication that happens allows you to increase the amount of force being exerted. You can probably take a few minutes and watch the how it works video. If you want to pause, if I've sent the link, you could watch it now. Otherwise, we'll probably watch it at a later time. We actually have a hydraulic system in our body. So the circulatory system that's pumping blood through our body is really a hydraulic system. We have a series of tubes called blood vessels, and it is one of the most efficient hydraulic systems known. We have constant beat of the heart, pumping blood, which is under pressure, through the body's arteries, veins, and capillaries. So that's the three different kinds of blood vessels that we have. The heart creates enough pressure to squirt blood more than 9 meters away. That's pretty impressive. Circulates all the blood in our body 3 times every minute. Pneumatics. So this is the last section for 9.2. We've talked about hydraulics. Remember hydro, the first part is referring to liquids, fluids. Usually we tend to use that one talking about water, but it's referring to fluids in this case. So applying a force through a confined fluid, or a fluid that's in a container. In this case, pneumatics is the study of pressure in gases. So hydraulics was study of pressure in liquids. This is in gases. The PNEU, pronounced new, like in pneumonia, is relating to air, gas, or wind. So that should be a hint that new at the first remind you it's to do with gases, whereas hydro in hydraulics refers to liquids. So a pneumatic system is a system in which a gas, instead of a liquid, a gas, is used to transmit and build up force in an enclosed space. It uses compressors in order to compress the gas particles and build up air pressure in the enclosed space. And then oftentimes that gas will be released in a way in order to power something to happen. When the pressure is released, the particles move apart suddenly, creating a force that can power or perform powerful tasks. And sometimes you can even kind of hear a gush of air as the particles are being released. So if you think of some different machines or things you've heard where you kind of feel or hear a whoosh, a sudden release of gas. Those would be good examples. ABS brakes. Okay, jackhammers. You can hear the gas being released as a jackhammer is acting. Dentist drills. A nail gun, that's a really good example. If you've seen or heard them, maybe on TV or someone doing some work in your home or out around building something, you can hear the gush as the nail gun is being used. The gush of air. Oh, already mentioned this one, so air brakes, ABS brakes. And that's it. So we've already looked at the objectives for 9.1. I'll be giving you a handout that has objectives for both 9.1 and 9.2 on it. But this second section, it dealt with pressure, how it's related to force and area. We did some calculations dealing with pressure, force, and area. And today we've talked about compressibility, what that means, the fact that gases are compressible, but solids and liquids, there's not enough space between the particles for them to be compressed, so we say they are incompressible. We looked at static pressure and Pascal's law and how that is the main principle that governs hydraulics, right? So in hydraulic systems, it's the transferring of a force through a liquid that's in a confined space. We looked at some examples, and now the latest was talking about pneumatics. And in pneumatics, how you have a system where basically the force is going to be transferred through release of a compressed gas. So that sudden movement of the particles as they're allowed to be released from their compressed state can power certain tasks. Think of that jackhammer or nail gun. Okay, so that's it for 9.2. Hopefully next day we'll get to do some work on a bit of research for your project. We'll have some time to do some review before you have a test. If there's time left in class when this is done, you can take out your worksheets and continue practicing the problems for pressure, force, and area calculation.